Woohoo! And welcome back. Today we're going to be working with yet another example of a profit function and all the various things we can learn from it. In order to help us out, I've invited the friendly, sparkly vampire to join us. It's a little known fact, but vampires are not just interested in counting, they're also really shrewd business people. You have to develop some serious business chops if you're going to sustain a castle for hundreds of years. It's a very expensive proposition, so they tend to be very good at business and accounting. So let's go ahead and get started. This problem did come right out of our book, and it says, suppose a company has fixed costs of $44,800 and variable cost per unit, and that's going to be a really important note. So I'm going to move the vampire, pardon me, vampire, and I'm going to just underline the per unit because that's going to come in later. We're going to use that. 4/9 x plus $333. So clearly, whatever it is we're talking about, these are expensive items. We've already got really big numbers in play. Where X is the total number of units produced, suppose further that the selling price of its product is 1,961 minus 5/9 x dollars per unit. And again, notice this is price. This is not revenue. So we've also got this per unit. And so let's go ahead and go through the analysis. So the first question is find the total revenue function R of X, or as I've been calling it, just simply the revenue function. What the book is doing, I think, in calling it total revenue is reminding you that if we're just giving the price, that in order to come up with revenue, we can't just use the price because this is just how much we make off of one unit sold. We actually need to multiply by the total number of units. So you might recall back from the very beginning of this class that revenue is equal to price times X, the number of units we sell. So in this case, price is right here, and I'm going to underline that in blue. The selling price is right there, and that's this guy, which is going to be right here. That's 1961 minus 5/9 x, and then we have to multiply times x. So altogether we get 1961x minus 5/9 x squared. And how did I get that? Well, of course, I distributed the x through. So there we go. And generally speaking, to make the parabolas make a little bit more sense, I have tended to put the x squared first. I put this in descending order. But honestly, you can choose to write it this way or this way. It's the same, it's the same meaning, it's just a different presentation. So there's our total revenue function. Okay, so far so good. Now I'm going to go into the cost function. This is going to be total cost function. So remember, cost is a bit more exciting, a bit more complicated, because we've got to include our variable cost plus our fixed cost. Okay, so we've got fixed costs up here. It says fixed costs are 44,800. Let's see, I'm going to run out of distinct colors pretty soon, aren't I? I think I can get away with a pink here. There's the fixed cost. Oh my goodness. I wasn't expecting it to be that bright. That's very exciting. Okay, so that's the fixed costs. And then I'm going to use, I'm hoping these are distinct, and I apologize if they're not, for the variable cost. Okay, they're pretty close, and I apologize. So I'll try to really point this out. The variable cost is right here. And again, I'm going to remind you that this is the variable cost per unit. So let's look at this. The variable cost was 4/9 x plus 333. But if we just leave it like that, that's just the variable cost for one unit, right? It says per unit. So just one unit is that. We want the whole variable cost. So we have to multiply by x, just like we did up there. I'll exaggerate, emphasize it by writing the multiplication. So this is the per unit part. So when it says per unit, to find the total, you have to multiply by x. So always watch for that. If this had just said the variable cost and it left out the per unit, and it just said variable cost is this, then we wouldn't need to put in the x. The x is because it's per unit. And then the fixed costs are 44,800. So, and again, that could be, we have no setting for this. We have no specifics. So this could be the lease on the plant or the cost of electricity. If if this is a Bitcoin manufacturing mining operation, a lot of electricity. And actually, I take that back. Electricity for mining Bitcoin would probably go into variable cost. I'm not sure. We'd have to discuss it. That would be a really interesting thing to talk about. I'd need to know more about how they mine Bitcoins, but I know electricity is a big part of the cost. I don't know how much of that electricity is fixed and how much is variable. So that would be a really cool thing to look into. I will put that in my head for another day. So, but the fixed costs are whatever is the cost of just running the operation outside of producing the actual units. Okay, so let's take a look at what we've got here. I'm going to again use the distributive property. I get 4/9 x squared plus 333x plus 44,800. And that's our total cost function. Now, right now, if you're looking at this and thinking, oh, this is going to be impossible, look at all the fractions. And of course, our sparkly vampire friend loves fractions, right? Loves it. But you might not love fractions. But I would say, courage. This is 5/9, negative 5/9. This is 4/9. Huh, that's interesting. That's almost like someone set this up to not be so hideous. And that is actually what's going to happen. So let's go to the next problem. Find the total profit function. So I'll remind you, the total profit function, people, race, cars. And I know that's a really odd thing to say, but that was something that a class came up with, oh my goodness, probably 10 years ago now. But to remember that profit equals revenue minus cost, profit or people, race, cars, and that stuck. Everyone in that class loved it, and I've been saying it ever since. So let's go ahead and figure out what this is. I'm going to use big brackets for this just because I always feel like big brackets help me handle larger things. So the revenue function is going to be negative 5/9 x squared plus 1961x. And I'm going to subtract cost, 4/9 x squared plus 333x plus 44,800. Okay, and if you would like to do this with parentheses, feel free. You need to use something. Because we're subtracting the cost function, we need to remember that the minus has got to go through and distribute to every single one of those terms. So parentheses or brackets or even braces, if you want to get fancy, they're necessary. Okay, so being that the revenue comes first, I'm going to go ahead and just write that out. There's no distributive property for the first part. Now I'm going to remember that the minus is going to go to each of these. So I get negative 4/9 x squared minus 333x minus 44,800. Okay, so all of those are negative. And then what's nice is I see that these are both negatives. And I've got negative 5/9 x squared minus 4/9 x squared. So altogether, I've got negative 9/9 x squared. Okay, so those two go together. Then the x's, I've got 1961x minus 333x. Oh my gosh, I gotta tell you today, it's not one of those days when I trust my brain to do math. So I could do it in my head or I can just double check it. 1961 minus 333 is 1628. So I've got plus, sorry about that, plus 1628x. And then that fixed cost is the only constant I have, so I don't have to work that out with anyone. Woohoo, yay! And then the only thing I need to do is recognize that somebody was looking out for us, because negative 9/9 is really just negative 1. Woohoo! So that's the first part. We've got revenue, we've got cost, we've got profit. Now let's go ahead and do some analysis on all of this. Woohoo! So next page. Okay, first thing, break-even points. Remember that break-even points are those points when either revenue equals cost or profit equals 0. And so you can do that with the revenue equals the cost. You can set these equal to each other, or you can simply go to the profit function, which I have to say I usually like, because the profit has it all, squished together. So all the information that's shared with the revenue and the cost all stuck together into one. So I'm going to use profit. If you would like to set these equal to each other, you think that's easier or you prefer it, go for it. You do you. Okay, so I'm going to choose profit equals 0. And so I'm going to copy this down. The opposite of x squared plus 1628x minus 44,800 equals 0. Oh, yay. And everyone's like, oh, yay. It's time for Quadratic Formula, man, woman, person. I don't have a puppet for that, but I will say that Sparkly Vampire's also very good at the Quadratic Formula, so he's right there helping us out. Thank you so much, Sparkly Vampire. So I'll remind you, x is the opposite of b, plus or minus radical b squared minus 4ac all over 2a. Why do I keep writing that out? I keep writing it out to make it easier for everyone to learn it. If you write it and say it and say it and hear it, it'll sink in, and then you'll know it forever. Okay, so I'm in a bit of denial, but we can do this. Sparkly Vampire says we can do this, and then I say, well, it's easy for you to say, Sparkly Vampire, you're immortal. So if this takes 1,000,000 years, it's fine for you. Probably won't take 1,000,000 years, though. Let's see. And then the question that some people ask, can we just factor this if we know how to factor it? And the answer is yes. If you are very excellent at factoring, it turns out this one does factor. And it's not that, believe it or not, I know this looks like, oh my gosh, how would you ever factor this? But it turns out it's actually not that hard a factoring problem. So feel free, go ahead and factor while the rest of us are just sitting here working on this when it's nice and beautiful outside, and we would really like to go outside. But instead, we're doing the quadratic formula. Always so much fun. You know it's the best. Yay, I don't want to be outside. I want to be doing the quadratic formula. There we go. Sorry, it's a little jiggity-jaggedy there. And then over 2 times -1. Okay. So let's see. I've got negative 1628 plus or minus. I'm going to work this out all over -2. Okay, let's get out our calculator. So I've got 1628 the quantity squared. Yay! And then I'm going to subtract, and then I've got 4. Now, why do I know it's subtraction? Well, because I've got a minus, and a minus. 3 minuses mean the whole thing is going to be negative, so I'm subtracting. And then it's going to be 4 times -4 times -1, which ends up being just 4 times -44,800. So I can just do 4 times 44,800 equals, oh my goodness, this is looking hopeless. I know I just told you that this turns out. I really hope it does. Okay, now on my calculator, it turns out that to take the square root of something you just came up with, I go ahead and I say second x squared to get to the square root. See, there's my square root function. And then I say of the last number I calculated, I do second and this guy that says answer, ANS. Woohoo! See, it turns out nicely, believe it or not. So this is -1628 plus or minus 1572 all over -2. Okay, I won't put this too far away because I know I'm going to be using this again. Okay, I know I'm squishing in. I wasn't sure how to space these out, but clearly I needed just a little bit more space. Okay, so I've got -1628 plus 1572 all over -2, or -1628 minus 1572 all over -2. So, -1628 plus 1572 equals, divided by -2 equals, okay, so we've got 28, or -1628. And remember, when you're doing negatives, I should pull this up so you can see it a little better. I don't want you to get blinded. Remember to use the negative key and not the subtraction key. Many calculators cannot tell the difference. Some can, but most calculators right now have this is opposite and this is subtraction. The big difference is that in some smartphone calculators, and if you're using Google, the just built-in Google calculator, I think they both just use the minus sign interchangeably. They're smart enough. Okay, minus 1572. Now notice what I did. I did the opposite of 1628 using this key, and then this is a subtraction. A sign that comes between the two counts as a subtraction. Minus 1572 divided by -2 equals 1600. So why did I say this is a relatively this is a relatively easier factoring? Well, because 1628 is that middle term, and it just breaks into 28 and 1600. So remember that these are the x values so that your profit is 0. So if you make 28 of these things and sell them, or 1600 of these things and sell them, you will break even. And then presumably everything in between these two numbers is going to give you profit. Woohoo! Sparkly Vampire is very excited. Woohoo! He's going to put in another Gothic fireplace in his mansion. I know, he's got a lot of them, but you know, when you're undead, you just can't warm up. You can't get enough. So you know, fireplace is important. Even though vampires, you know, have some trouble with fire. They have to be very careful. So fire safety is also key. So you want to build these fireplaces very carefully so there's not going to be, you know, any, you know, surprise fires in the rest of the mansion. Okay, let's go to maximum revenue. So we want to know what what number of units will maximize the revenue. So if I go back to my first page, I see that my revenue function is -5/9 x squared plus 1961x And I'm going to do that thing where we draw just a little box because the two problems are getting too friendly. And I'm going to say, okay, this is, in fact, a case where revenue is, when you look at the graph, this is a parabola, it opens downward. So the maximum revenue is going to be the vertex. So we have the formula for vertex. X equals the opposite of B over 2A, which again, I'll remind you, you don't have to memorize this separately. It's just the beginnings of the quadratic formula. So if you just cross out that part of the quadratic formula, you get that vertex point. So, and remember, we're not working with profit, we're working with revenue right now. So that's the opposite of 1961 all over 2 times the opposite of 5/9. And I know everybody's like, oh no, why would you do this to us? And the answer is, because I can. That was a terrible answer, wasn't it? Okay, so I didn't actually do this, the book did. Okay, so let's see, this is negative 1961. Now I've got 2 times negative 5/9, so I'm going to write this as negative 10/9, right? I've doubled it. Now, the first thing I notice is that they're both negative, so I'm going to cancel out the minuses. And then I'm going to use, I'm going to say 1961 divided by 10/9, which is 1961 times 9/10, which is equal to, and right now I'm already seeing I have completely underestimated how much space I was going to need, so I apologize for that. 1961 times 9/10, that's 1961 times 0.9. Oh my gosh, everybody's happy. We're back in decimal land, and 1961 times 0.9 equals 1,000, so 1764.9. And immediately you go and check your answer, and the book says, nope, that's not correct. So why isn't it correct? Well, if we look here, we see it's asking for the maximum revenue. And then we see right here, X is equal to this. So this is the X value at the vertex. So that's this value. That's where X is. That's not what Y is. So then we have to go ahead and plug in 1764.9 into revenue. Now, it is fair for you to say, wait a minute, if X is the number of units, we can't make 9/10 of a unit. And the answer is yes, that's correct. However, when we're doing math, we always work things out exactly and round later. Now, if this problem in the real world were, how close can we get to maximum revenue, then what you might want to do is you'd say, well, let's take a look at 1765 and 1764, right? You can compare them and see which one makes more sense. But I'm going to go ahead and do it exactly because, again, it does not say anything about rounding here yet. It is going to say that down there, but I'm not going to. So let's see. I have to plug this back into there. Okay, you ready? So I'm going to get -5. You know what I'm going to do? Let me show you how to do this. I'm going to do the opposite of, and I'm going to open a parentheses, and I'm going to do 5 divided by 9. That's going to give me my fraction, so I don't run into problems with the order of operations. Then I'm going to say times, and I'm going to say 1764.9, the quantity squared. Do you see me doing that's the first part, squared. Now, because I'm old school, I learned to go ahead and stop there, hit enter, but in fact, calculators can handle this now. So I'm going to go ahead and add 1961 times, and again, I have to type in the X, 1764.9 equals, and then I got 1730,484.45. Ooh. So, my revenue at this number of units, which again, we agree we cannot produce and sell this many units, but we're just going to work it out exactly. That would be my revenue at that point. And I included the dollars because this is revenue. Okay, so that's my maximum revenue. All other numbers of units, more or less, will end up with a smaller revenue. And when everyone says, well, why would that be? If you make more, shouldn't you make more? And the answer is no, because as you sell more units, as we try to get X to go up, remember what we know, because of the demand equation, the selling price starts at 1961, and then you subtract this fraction, 5/9, about 1/2, so about 50 cents per unit that we want to sell. Because what do we have to do? If we're going to sell more in our setup, we can't just advertise more. We can't do other interesting things. The only thing we can change is the price. So in our model, we just change the price. How do you get people to buy more? You lower the price. So the thing about revenue is that if you want to sell more of them, the price is going to shrink. And then when you multiply the number you've sold times the price, it could actually start decreasing. Okay, so that's our maximum revenue. We kind of squished that in. Okay. Still, I'm sorry that it got a little bit squishy. Let's go to maximum profit. Okay, maximum profit. Our profit function is the opposite of x squared plus 1628x minus 44,800. And oh my goodness, thank goodness, because again, we are looking at a quadratic, so we're looking at a parabola that opens downward. Yay! So our maximum profit is going to be, again, the vertex. So we use our formula for vertex. X equals the opposite of b over 2a. We say, thank goodness, no fractions. The opposite of 1628 all over 2 times -1. Negative 1628 all... Oh, sorry about that. That's confusing. My hand sometimes likes, riffing. It's just... This is not an opportunity to just make up some interesting stuff. So negative 1628 all over -2 is negative 814 over -1, I think. But you know what? I don't trust myself. Yes, it's 814. And yet again, this is units. This is units. And in fact, I didn't write that up there. So let me just, while I'm going after all of the units. So this is 814 units. I want the maximum profit. So I need to take the profit of that many units. Okay, so yet again, let's plug this in. I've got the opposite of 814 squared. Right? The opposite of 814 squared plus 1628 times 814 minus 44,800. Okay, so the opposite of 814 squared. Notice that I can just type that in. My calculator understands order of operations. Plus 1628 times 814 minus 44,800, and I get and this is very disappointing, right? Our maximum revenue is almost 2 million. So in a perfect situation where we're making almost 2,000 units, I've maximized revenue. But the problem is two things come up. Revenue is just the money you bring in, and it doesn't take into account the costs. And interestingly enough, because of the way that demand and the price interact, it turns out that I don't actually maximize revenue and cost and profit at the same time. The maximum profit is half the production. I maximize profit at 814 units, not 1764. And so you might ask, well, why even bother with revenue? Well, once you go into business, you find out that there are different goals. Some companies may be looking to maximize profit. Some might be looking to get closer to the maximum revenue. It could be that you're just looking to get a lot of your product out in the marketplace. You want to, make sure that you keep out all the other folks who want to make whatever it is you're going to be making. Okay, so our maximum profit is only 617,000, but let me remind you, profit is the money that comes into the company after you've paid all your costs. And traditionally, costs include all of your salaries. So everyone's getting paid. This is the money that the company earns as an entity, as its own, voting creature. The company can then go out and buy itself something nice, like maybe 617,000 would buy you a new, well, it wouldn't buy you a new building, but it might buy you some new equipment. Certainly you could buy yourself possibly, some new factory equipment if that's what you're doing, or some new computers for your employees, or a nice new, you could remodel the break room or something. So the company could take this money, invest it, save it, so there are a lot of things the company can do. This is the extra money it gets. Okay, so the last one, and this one always really annoys people. What price will maximize the profit? And everyone's like, oh, why do I have to do this? And the answer is because if you are a business, you can't just go out into the world and say, okay, everybody buy 814 units and go. You cannot tell consumers how many to buy directly. However, using the demand function, the selling price function, so our price is, what was it? 1961 minus 5/9 x. So for this one, we can't tell people to buy 814 items or units. However, if we've done our research correctly, then what we can do is we can say, okay, we take 1961 minus 5/9. I want to sell 814 of these things. Okay, so let's go ahead and clear this out. 1961 minus, and then I'm going to do my fraction in parentheses to make sure that fraction doesn't get wonky, times 814 equals, and then I get 1508.777. And again, if you see a bunch of sevens and then an 8 on your calculator, then what you know is that this just keeps going on. It's a repeating decimal. And we're supposed to round to the nearest cent. So cents. So American dollars are counted to 2 decimal places. So I'm going to round to 1508.78, right? Because this one, the very next number is 7. That's greater than or equal to 5, which means I round up. So what am I doing? Well, you can't go out into the marketplace and say, everyone has to buy 814 of these exactly. But what you can do is you can say, okay, here's our price. Our price is set at 1508.78. And then if you've done your research correctly, and if this demand function is correct, which granted, that is actually a very difficult thing to do, right? You might make a good prediction for today, but tomorrow, who knows, right? So if you have, though, and you set the price to 1508.78, that's the price that faces consumers, they will automatically buy 814 units, which maximizes your profit. Isn't that cool? It's very cool. Okay, so one more thing. I know you guys have sat through the longest video in the history of videos, but I've got one more thing I want to show you. I have used Desmos to graph this beautifully, so you didn't have to suffer through me graphing poorly, because this is a very hard function to graph. This is profit. So this is the graph of the profit function. And notice I've added arrows. And I'm going to add an arrow over here. This is profit. And then I'm going to do something interesting. Can we include this part? Nope. Why not? It's part of the graph. Yes, it is. I'm going to yellow or white it out. Why do I have to white it out? I'm going to put a little point right there. We have to white it out because this over here is when X is negative. We can't sell negative units. So we always start on the y-axis, or in this case, the p-axis, when we're talking about this model where we're selling units. Okay, so what have we got? Well, this, believe it or not, is the negative, so let's see, 0, negative 44,800. That's the fixed cost. Okay, right here, this is the max profit. Remember, the max profit was, oh my goodness, I have to look it back up. At 814 units, we're making 617,796. And so that's, and you can kind of see this is like at 814, a little bit more than 800. So the max profit is up there. And then we've got 2 break-even points here and here. Now, because this graph is so big, the scale makes it hard to read off the graph, but these are the break-even points. And I don't know if you remember, one was at 1600 and something. One was at 1600 and one was at 28, right? So these are X equals 1600, oops, or 28. Okay, there you go. Thank you guys for making it through a rather long video. Hopefully this helps to make profit make a little bit more sense. And woohoo, go out, change the world, make some money. Don't forget to take a nap. Have something to drink. You're probably dehydrated. I can almost guarantee you're dehydrated. So have something to drink, go out, look at some green for a little bit to give your eyes a rest. And, you know, woohoo, math on. You guys are awesome.